Hello there. Today we're going to try to sketch this tan graph here, and basically it's y is equal to 2 tan of 3x minus 5 and 6 minus 1. Now the first thing we do, we're going to try to find the vertical asymptotes of our graph. Initially, the y is equal to tan x, which is the initial tan graph, has two vertical asymptotes initially from minus pi upon 2 to pi upon 2. So what we see here is that the period between the distance between those two vertical asymptotes is basically pi. Now, these are the first thing we're going to try and find out. We're going to find the period as well as the vertical asymptotes of this new graph and look at other transformations which this graph that we are going to sketch has undergone. Okay, so what we're going to do is we're going to try to find the period, and we know that the period is, if you have a tan graph, generally you have the tan graph in the general form A tan of bx plus c bx minus c and then plus d. So we have an inside function which is bx minus c, and the A is basically, the tan graph doesn't have an amplitude, mainly because we have vertical asymptotes. And the vertical asymptotes actually, when you draw your curve between the vertical asymptotes, they won't have maximum and minimum points. They would rather be compressed or stretched, and that's what we call 2 here is the scale factor of the graph being compressed or being stretched. And so we're not going to be worried about the amplitude because it has no amplitude. And so the period is for a tan graph is, because it's a periodic graph, so the period is given by pi over b, and this is our b here, and our b turns out to be 3, so the period is now pi over 3. And also, what about the vertical asymptotes? So we're going to set, okay, the inside function, okay, to the initial vertical asymptotes. A vertical asymptotes are minus pi upon 2 and pi upon 2. So the inside function is 3x minus pi upon 6. Now that's going to be set to plus or minus pi upon 2 plus any successive vertical asymptotes which is going to be equal to n pi, where n is an integer. So n is an integer. And from here, we can try and solve this. So we have 3x is equal to pi upon 6, okay, plus or minus pi upon 2. We're not going to be needing this for the time being because we're just trying to sketch the graph between the first two vertical asymptotes. So I'm going to ignore this for the time being. And so now we have x, if we divide by 3 on both sides, pi upon 18, plus or minus, over here it's going to be pi upon 6. Now pi upon 6 is the same as 3 pi upon 18. So here we are. So the vertical asymptotes then is going to be equal to the initial ones, the initial vertical asymptotes, turns out to be, first of all, pi upon 18 minus 3 pi upon 18 is going to be equal to minus 2 pi upon 18. And then you've got 4 pi upon 18. If you add them up, should come to 4 pi upon 18. And also, you can check out that the period between these two is going to be pi upon 3. So if you were to find the distance between these two, it's going to be 6 pi upon 18, and that 6 pi upon 18 means pi upon 3, which checks out with this. So this is great. Now this turns out to be okay, and it's correct. And also now there's another transformation with the graph. But before we go into doing that, remember our initial graph starts here from 0. So this graph here will not start from 0. It will have a phase shift. Because look at the inside function, we have 3x minus 5 and 6. So that changes the phase shift from 0 to something else. So we're going to set this one to 0. So for the phase shift, we're going to set 3x minus pi upon 6 to 0. So this becomes then pi upon 6. The 3 gets divided there, and so x is going to be equal to pi upon 18. Now, that means our graph is not going to start from 0, but it's going to start from here. That's the starting point of the graph. Okay, so we have enough number of points here, key points, to be able to actually sketch this graph. But let me just look at another one important thing here. Sorry. We've got a -1. That means the graph is going to be shifted down by 1 unit. If it goes +1, it would have been shifted up. But now it's going to shift down by 1 unit. So now if I were to sketch the graph, but before I can sketch the graph, I can also find sorry, maybe the value of x when y is equal to 0. So for that, I need a calculator, but it doesn't really matter for the time being. So let's try and sketch the graph. So this is your y-axis, x-axis. So 0. I'm going to scale it like 1, 2 here. So -2 upon 18 pi. And so this one here is my first vertical asymptote. Then I got pi upon 18. This is, minus pi upon 18. 1, 2, 3, 4. So this is my the other vertical asymptote. 4 pi upon 18. 4 pi upon 18. So the graph now starts exactly in between, midway between those 2 points. Those 2 vertical asymptotes, I mean. So we have 1, 2, 3, 4, 5, 6. So the graph's supposed to start here, like this here. But now remember, this graph is shifted down by 1 unit. So my x-axis, which is the line y is equal to 0, is no longer the x-axis. I still have the x-axis, but the graph is not going to start from the x-axis. It's going to start from the new x-axis, which is the line y is equal to -1. So this one here, -1. Okay, so exactly where the graph is supposed to start here, we're going to draw a point here, and that's our starting point. So my graph is going to go from here all the way to here. Right, so this is exactly how my graph is going to look like. Okay, so I may have to sort of like, try to perfect this a little bit. Here we are. And remember, those values, where it crosses the y-axis, this is -1. Okay, now we know, so that normally it's not supposed to be like this. It's supposed to be like this here. Just hang on a sec. So that's, all right, okay. Right, so it's supposed to cross this at a certain point here, and then go all the way up from here. There we go. Now that point here could be found if this is a y-axis. Okay, you can set, you can just put y is equal to, let's say, 3x minus pi upon 6, pi upon 6, -1 here. You can set that to 0. And of course there's a, 2 tan of all of that is equal to 0. So I have 3x minus pi upon 6 is equal to, and if I were to send the 1 on the other side, becomes plus, and this is divided by 2, the tan goes there, becomes tan inverse of half. So if you were to solve this, let me just try and get a calculator here. So I'm looking for the tan inverse of 0.5. Turns out to be 0.464. And then, of course, the x can be found by taking this value here, 0.464, plus pi upon 6 over there, because this is minus. So you add it on both sides, and then you divide by 3, because that's 3x. So I'm going to add on pi upon 6. It turns out to be 0.987, and all of that divided by 3, and I get x as 0.329. So that's my value of x. Turns out that this is the value of x where it crosses the x-axis. Okay, and so, right, I'm just checking something. If this is perhaps it's going to go like this here, right? Yeah, okay, that's great. It shouldn't be too close here, but this is not accurately drawn. It's not drawn to scale, you know what I'm saying? So, but basically this is how your graph looks like. We can also find out where it crossed the y-axis. The y-axis is the line x is equal to 0. So if you were to substitute x is equal to 0 into the equation, you're going to get 2 tan of 3 times 0. So that's when x is equal to 0. So we're going to get tan of negative pi.6, because if we were to put 0 here, 3 times 0 is 0, 0 minus pi.6 minus pi.6, and then subtract the 1. Okay, so let's try and do that. The tan of negative pi.6, and then all of that being multiplied by 2 and take over 1, and I get negative 2.15. So that's negative 2.15. That's where it crosses the y-axis. It crosses this here. At that point here, I have 2.15, and so you can see it's supposed to be somewhere here, but that's okay. I mean, the graph goes like this now. All right. So I hope this makes sense. I mean, like I said, you know, this is not drawn to scale. I mean, we're not worried about the scale for the time being. We're just worried about the key points that's going to help you to sketch a graph like this, which looks very complicated. But end of the day, if you were to do all these calculations, everything else is going to fall into place. Take care. Thank you for your attention.